This conference will now be recorded.
Good morning, everyone. So, in the last session, we discussed about the scope and lifetime of this particular variable. And today, we are going to discuss one of the important concept here, like how we can come up with a type conversion. So, this is very important, the type conversion we are working here. And now observe. So, basically, the type conversion here. So, we can easily assign the value one data type into the another variable data type here. So, basically, in Java, what happens here? We can easily convert one data type value into another data type here. But here, what we need to understand here, so if the two data types are having, like two variables are having same data type here, so this particular values are automatically converted. So we don't need to write any explicit logic here. Getting the point? So whatever the two variables we are having, the two variable it needs to be same data type here. Then we can easily typecast the variable one data type into the another data type here. But the problem here, so the automatic type conversion will not perform whenever we are having so different data types. What are the different data types here? So for example, here we are having first one is double, getting the point, and another one is byte. Another one is byte. How we can convert this double to byte or byte to double? And here we need to understand one more information. So we can easily convert small data type into the bigger data type. So this is the small data type, like it's nothing but range here. And these are all the big data type here. Getting the point? We can easily convert the small data type into the big data type. If you observe, byte is the smaller data type, convert to this particular double. So this particular conversion is we can perform happily. But the problem, whenever we are trying to convert double to byte, because double is a some bigger data type and byte is a small data type. So this particular conversion will fail. This particular conversion will fail here. So this kind of conversion, we need to write explicit casting here. Getting the point? We need to write this particular explicit casting here. So how we are going to write? So as I explained here, first we'll check about the automatic type conversion. Whenever the two types of compatible, whatever the two data types we are using, if the two data types are compatible, we can easily use the automatic type conversion. And only the problem when we are having different data types here, so then only we are going to use the explicit typecasting here. Okay, so let's have a simple example how we can use this. Now I'm going to come up with a new class here, and here what I'm doing here, so class I'm creating, what is the name of the class? Something like conversion. So the name of the class also important here. So what is the name we are giving, and by saying the name of the class we can easily understand what exactly the class is going to do. Okay, so conversion I'm trying to define here, and after conversion I come up with a main method. So as I explained here, you can use any variable name. Not only the args, we can come up with any variable name other than this particular data types and keywords. Okay, so now I come up with a main method. So once we created this particular main method, now what I'm doing here, so byte b getting the pen. So just I'm trying to declare the byte b, and int I is equals to 257. Getting the pen. So int I is equals to 257, and one other one double d is equals to 323 dot something like 145. Okay, so the fractional values I'm giving because it is a double data type here. Right, now observe what I'm doing here. After defining and initializing the value, so I'm going to convert this. Getting the point? I'm going to convert this. So how I'm going to convert here? So as I explained here, whenever I'm trying to convert into 2 byte, because int is a some bigger value and byte is a small range of this particular data type. But how we can convert? Now if you see b is equals to, I am using I. B is equals to I. So whatever the I value we are having, I'm trying to assign into this particular B value, like B variable. Now let me print this system dot out dot println, and here something like a b value. Okay, here I will give you this particular b, and after this I'm not going to write anything right now. So we'll check what happens here. The line number 6, it will convert or it will give any error we need to understand here. Okay, so I save this particular file. Now I'm moving into this particular cmd and java c conversion.java. Now if you see what happening here, we are getting an error. Now you can read this particular message. So you can see possible lossy conversion from int to byte. Why? Because these two are the same data type. Like this, these two int and byte, these are all like come under the integer category data type only. So these are the two data type will take only same data type value, but only the problem range here. The problem only here range. So whatever the value we are giving, this is outside of this particular range here. So what is the range we are having the particular byte here? So something like minus 128 to 127. So if you say this, the entire the range value we are going to get as a 256 here. Okay, now observe carefully. So this conversion is failing. Now how we can come up with a typecasting here. So here what I'm doing here, I'm going to use byte. Getting the point. I'm using this particular byte. Now let me compile one more time. So any error we are getting right now, we are not getting any error. So if I'm going to execute this, what is the value we are getting? 1. So why we are getting the 1 here? Basically, what is the value we given? The I value. I value we given as a 257. I value we given as a 257. But once we convert it into this as a byte data type, we are getting as a 1 value. So how it is converted? Basically, we need to check about the range here. The range value of this particular byte, we are having 256 here. Based on this particular 256 here, now what happening internally? It's going to come up with a division operation. It will look like this. Getting the point? So whatever the reminder we are getting here, this particular reminder is going to store into this particular byte here. So this is important here. Getting the point? Because of the particular range is smaller. So yesterday we discussed about the different example. In that case also we get the different output here. So what we expected, but we got the different output here. Now I think the output how it is converting. Now we identify. So we identify the this particular example here. Okay, now if I'm going to use this, so byte I converted the int value I converted into this particular byte. So now you can see if I'm going to give 456. So at this time, what is the value we are going to get? Compile and execute. So what is the value we are getting? 56 here. Getting the point. Same logic. So whatever the division we are having the range, so we need to divide the particular value and later we can get the appropriate output here. Okay. So this we need to check about the based on the range, it will work on the division operation. And one more data type here. So now we converted into 2 byte. Now I want to convert. Now I want to convert. So the double data type into data type here. Okay. So now what I will write here, first I will write the message println, and here inside this particular println, now what I'm doing here, so conversion of this particular double to int. Okay. Now how we can convert the double to int, because double is a some bigger data type and we cannot convert the int value into this particular d. Okay, if you see I is equals to d, I is equals to d. Now here, what I'm doing here, I want to print this particular I value, and here we should give Getting the point. Now, whatever the d value we are having, we are converting into this particular I. And now observe what happens internally. Compile this. What happened internally? Now you can read the same message here. So you can see again the conversion is failed from double to int here, because double is a some bigger data type and we cannot convert it into this particular int here. Getting the point. Now what we can do, again we need to come up with a explicit typecasting. So how we are going to write something like this. So which data type we are converting, we need to define the data type here. So earlier I converted into the byte, so I define as a byte. Now I'm trying to converting into this particular int here. I'm trying to defining into this particular int here. Okay, now observe the main important we need to understand here when we are trying to converting double to int. So whatever the fractional component we are going to have, like after the dot, whatever the values we are going to have, those values are not converting into this particular int. So before the dot, like before the dot is nothing but, so these are the values 323. Getting the point. So this value only it will convert into this particular int, and compiler it will ignore this particular value. After the dot, whatever the values we are going to have, it will ignore whenever we are trying to converting double to this particular interrelated data types here. Even if you convert the byte to short, or if you convert the long, for all these four data types, the fraction components are going to lose here, right? So now compile one more time. So it's compiled successfully, and now I'm executing this. So what is the value we are getting? This 323. So why the value is not modified here? Whatever the value we are having, the value within the range here. Whatever the 323, that is a range within the range of this particular into data type. If it is outside of this particular range, so again it will work on the same the division operation and it will convert here. Okay, and so this is very important. We need to understand here how this particular double value is converting into this particular I. And what about the final conversion here? So the final conversion here, I'm trying to work double to byte here, and here we can use the byte. So here, what is the data type I want to give? Byte I want to give, and here what we can give, something like b. Getting the point. So this is important here. So this is the way we can convert the particular byte data type into, sorry, double data type into this particular byte here. Compile one more time. Now it's compiled successfully, and execute here. So now you can see what is the value we are getting here. Something wrong. Here I modified this B. Plus 323 is also out of range of this particular byte here. So I forget to modify the reference variable here. Now I modified this, and compile and execute. Now you can see. So what is the B value we are getting? Something like 67. Getting the point. So this is very important. We need to understand here. Any questions regarding this particular explicit typecasting here?
Can you please show line number 6 again, the division expression again, how we are doing?
So basically, we need to understand the range. The range of this particular byte, it's a 256. So whatever the some bigger value you are giving here, it's going to divide with the 256 here. Whatever the reminder we are getting, the reminder value will store into this particular byte data type, not the original value. So if you see, so if you use this particular 323, so now let me know how many times it's going to so multiply this particular value. If you do this particular operation, we'll get the whatever the output we have seen here, something like 67 something that you are going to get. So you can do the calculation on this, you will get an output here. The whatever the reminder we are getting this, so this particular value, it's going to store into this particular byte data type here.
Okay, got it.
Sir, so for byte, it is 256 divided by 256, right?
Yes.
Okay, thank you. For int, it was 127, I believe.
127.
For int, it was 127.
Basically, most of the time you are not going to use the conversion, it's not going to use this division, because the int is also some big range value. So we can store, if you are overriding the range, because it is moving into the quotes, so we cannot give that much value. If you are giving, again it will check for the range. Based on the range, it will convert the value. Okay, so any other questions? Okay, now, yes, tell me. Okay, so we'll move on to the one more example here. So how we can come up with the automatic typecasting here. This is very important here. So the explicit typecasting we identified. Now we need to understand the automatic typecasting here. So for example here, now what I'm doing here, I'm going to comment out this entire section, and here I will try to write one more example. So byte A is equals to something like 40, byte B is equals to something like 50, and byte C is equals to 100. So these are all the three variables I'm declaring here. And now what I'm doing here. So if you see, I'm trying to multiply. So A multiply B, and I'm trying to use division operation with the C. So here, if I'm trying to use this, byte D is equals to this particular value. So again, here we are going to get an error here. Here we are going to get an error. Now if you observe carefully, so why we'll get an error? Let me compile one more time. Now you can see. So why we are getting here into 2 byte? Because if you observe carefully, all the data types, whatever the data types we are using, byte data type, but still, so it's checking int. From where this particular int is coming? Because we define the 4 variables are having same data type here. Getting the point? So here, what we need to understand here, whatever the result here, if you do this multiplication and division, whatever the result we are getting, the result compiler will treat as a int, not this particular byte here. Getting the point? So this is important, we need to understand here. Whatever the result we are going to get, by default, the compiler will treat as the result as a int here. Getting the point? And if you're trying to converting again the int to this particular byte, it's giving you an error here. So if you see, so either you can come up with this particular byte, or what we can do, otherwise we can define this particular int data type here. So compile one more time. Now you can see still we are getting an error, because so basically we need to use this particular expression as a type conversion first. So then only we can happily convert the value. So still basically the result here. Again here if you see A multiplied with B, so it's returning int. Again we are trying to converting with this particular int value with a byte. So still we are getting here. Now what is the best way here? Now use this particular parenthesis here. Now it will take highest priority. Inside this particular parenthesis, what is the value we are going to give? It will take highest priority here. Now compile this. Now you can see whatever the compilation we are getting earlier, the error is resolved here. Getting the point? So not only this, if we want to execute this as a statement as a first. Now what we can do, we can come up with this particular parenthesis. So and whenever we want to give the highest priority, it will write under this particular parenthesis, it will take highest priority first. The parentheses are going to execute, later it will try to come up with different operations here. Okay, so this is important here. So otherwise, now what we can do, directly into d is equals to this particular a multiply b and do divided by c. Compile this. Now you can see without typecasting, it's compiled successfully. Getting the point. So this is also one of the important example here. Now you can what we need to think here, basically the result compiler will treat as a int. Any operation you are going to perform, the compiler will treat as a result as a int here. Now from this particular int, you are trying to converting appropriate data type here. Okay, so these are all the type conversion here. So if still anyone having any questions, please let me know.
Sir, even for addition and subtraction also, does the compiler treat it as int?
Yes, any
Okay.
result.
Okay. Thank you.
Okay, now what I want to move. So here we need to discuss about the arrays example here. This is very important example we are trying to discuss here. So far, what we identified here, the variable is holding only one value. So if we are trying to modify the value, the existing value is not available. So it's coming with a new value here. So the section of example we already identified in the previous example here. So for example, I come up with this particular into a. Yeah, I given as a 100 earlier, and whenever I'm trying to modify to this particular 200, the 100 will override with this particular 200 value. So because this a value can hold only single value, but if you want to hold multiple values, so if I want to hold the same variable with the multiple values, so what is the syntax we need to follow? And the same concept we are going to discuss, that we are going to call it as a arrays concepts here. Basically, the arrays here, it's going to store the group of variable. The group of variable here, like the group of values, those are going to have same data type here. For example, so as I explained here, so int value one I come up with 100 and another one I come up with a 200. But same way, if I'm going to use float, if I'm going to use this particular float, f is equals to something like 17.18. 17.18. What happens here? This will give you an error, because arrays concepts here, it will try to hold the multiple values, but all the values are having same data type here. Getting the point? So this is important here. And now how we can define this particular arrays here. So to understand this particular arrays concepts here, first what we need to understand here, type here. Type is very important here. This particular type is very important here. So right now, what are all the data type we identified? The same data types are we are going to use for this particular arrays concepts here. And observe, I'm using this particular type. Type is a data type here, and here we can come up with a variable name. Getting the point? And here we are going to open with this particular brackets here. So why we are going to open this particular bracket? So this will indicate that it's going to hold multiple values here, not the single values. For the single values, how we define? Just we define the type and variable name. So we did not use this particular brackets concepts here. Getting the point? So this will hold the multiple values. But here, what we need to understand here, whenever we are trying to work with this particular arrays concepts internally, it's trying to work on the indexes here. So this is very important here. If you understand this particular index concepts here, so you can easily understand the collection framework here, because all the, like most of the collection frameworks are implemented based on this particular arrays concepts only. Okay. So if you observe carefully, now we identify the type and a variable name, and which is expecting one bracket here, and internally based on this particular size, whatever the size we are going to give this particular array, it will come up like this. Getting the point? So for example, a size I given as a 0 1 2 3 6. So I come up with this particular 7. Size I given as a 7. Getting the point? Size I come up with a 7, and indexes are going to start with 0 1 2 3 and 4 5 6. Getting the point? Size will start from the 1, index will start from the 0. This is important, we need to understand. And here I'm trying to write here size related information 1 2 3 4 5 6 7. Getting the point? This is indicating size here. So what exactly the size will do internally, we need to understand here. And what exactly this index will perform here. What exactly this particular index will perform here. This is also we need to understand here. Okay, we'll see the simple example how we can come up with this particular arrays example. So the whatever the current example we are discussing here, this will call it as a one dimensions array. So once we familiar with this particular one dimensions array, we'll move on to the multi dimensions arrays here. Okay, now let me go to this. We'll come up with the one more. We'll use the one more class here, and inside this particular class, now what I'm doing here, I'm going to come up with the array example. Array example I'm trying to define, and after this, okay, I come up with the main method. Now you can see what is the type I'm using. The type I'm using as a int, and what is the name of the variable. So here I'm trying to use this particular month underscore days. So now you can see variable name I'm using as a month underscore days. And here, so what we need to define, this the particular bracket we need to define. Then only this particular variable can store multiple values, and all the values are having the data type called int. Okay. So here I'm declaring this particular variable. Now what I'm doing here, I'm trying to initialize. So how we are going to initialize here? So initialization, it's going to work like this. Month underscore days is equals to new int. So what is the data type we are using here? Int data type here. And here, while creating this particular int data type here, we should provide the size here. So size is very important here. Getting the pen. So without the size, we are not going to insert any values. This is important here. Without this particular size, we are not going to insert any values into this particular month underscore days variable here. So whenever we are trying to work with this particular arrays concepts here, so we should define the size here. And now how it's going to look like here. Again, it's going to look like this. So imagine here 0, 1, 2, 3, 4, 5, something like up to 11. So it will start from the 0 and it will end up with this particular 11, because 0 to 11 is nothing but 12. So it is matching to this particular size, and whatever the month underscore days variable we are defining, it will try to point it to this particular arrays internally. Getting the point? It is pointing to internally this particular arrays here. And now, so I'm going to insert the data. So just we are creating an object here. So this particular object does not have any data right now. Just it is a empty array. So just we define the size, and inside this particular array concept, all the values are 0. By default, these values are 0, because what is the data type we are using? Int. For this particular int data type here, all the values we are going to get as a 0. Okay, now, so we understand the declarations and creation of this particular array. And now what I will do, I will try to initialize the values. Getting the point? I am trying to initialize the values. So if we observe carefully how I'm going to initializing this. Now, here I want to use, so month underscore days. Now you can see this is important. Again, I'm trying to open the particular brackets here. Now I'm giving 0. So here, why I'm giving this particular 0? So basically, I'm declaring the index location. Getting the point? I'm declaring this particular index location, and I'm trying to initializing the value. So what is the value I'm trying to store in the which index location? If we observe, this is the 31 value. So as I explained earlier, what happens internally? The right side value will store into this particular left side, because we are working on the single equal. The single equal operator we are using. So the right side value will store into this particular left side variable. But here, while storing this particular left side variable, now what I'm doing is I'm defining this particular 0. So why I'm defining this particular 0? So whenever we are defining this particular 0, the value is going to store in the 0 index location. Here it will store the value in the 0 index location here. Getting the point? So this is important here. Whenever we are trying to work with this particular array, first we need to create the size, and second, whenever we are initializing the value, we should define the index here. We need to define this particular index. Now you can see if you come up with the some values. If you define the value, it will look like this. And in the second index location, so what is the value we can give? Something like 31. So some random values I'm trying to give here. Getting the point? This is the way we can store the value up to what is the length we are having, 12. So length and size is same, so 11. So 0 to 11 it's become 12. Okay, so let me initialize all the values here. Inside the 0, I'm trying to initializing 31. I will write multiple values. Okay, now what I will do, I will modify this. I'm giving second index location, and inside this particular third index location, something like 35. This is the fourth, and you can see not only this particular order, you can give any number. So you can come up with a 8, sorry. So you can come up with this particular 8, I can give the same 31, or you can give this particular 10 location, or you can give something like 45. And here we can give only up to the 11. So you can give the 12. So for example, if I'm trying to give this particular 12, so we need to understand what happens internally. Okay, these are all the values I'm initializing into this particular array. Observe carefully. After initializing this, now what I will do, I'm going to print the specific index here. The specific index. How we are going to print the specific index? Now, if you observe system.out.println, and whenever we are trying to print this particular specific index here, first what we need to define, we need to come up with a variable, whatever the variable we are trying to store the values, and you can open this particular braces and you can define the index here. So whenever we are defining like this, now what happens internally, because this is the reference variable which contain the all the arrays values here. Getting the point? So this particular variable, it will go to this particular third index location, and inside this particular third index location, whatever the value we are having, the particular value is going to loaded here. Okay, so now you can see this is a simple example I'm defining, and I will save array example, and Java C array example.java. Now it is compiled successfully, and Java array example. Now if you see, we are getting an exception here. We are getting an exception. So why we are getting an exception? This is very important. We need to understand here. So can you read this error message, like exception message, and understand here why we are getting it? So index is 12. Whatever the index we are providing, that is 12, and this is the outside of this particular length here. Outside of this particular length. What is the length we given? Basically, the length we given as a 12. So whenever we are giving this particular length, the indexes are it's going to work 0 to 11. But right now, the line number 13, what we are doing here, still we are trying to inserting with a 12 index location. But right now, do we have the 12 index location? No, we don't have here. So again, carefully observe. This is important here. Now it start with a 0, 1, 2, 3, something like 4, 5, 6, and something like 11. You can see 0 it started, it is ended with 11, because 0 to 11 it between the size which become 12. But now what I am doing here, this particular 12, so where this particular value is going to initialize, the 65 value, where it is going to initialize, because we don't have a indexes here, we up to we have 11 here. Getting the point? This is very important here. So whenever we are trying to creating this particular arrays concepts here, so once we specify the size, the values we need to initialize within the size only. If you are trying to initialize a value outside of this particular range here, so we may get this particular exception here. So whatever the exception right now we are getting, so that is an exception we are going to get. Now what we can do, so right now we can comment out this particular section. You can comment out the line number 13 here. So observe, I'm going to compile one more time and execute. So what is the value we are getting? 30. So why we are getting this particular 30? So that we need to understand here, because in the third index location, what is the value we are storing here? So 30. In the third index location, we are storing the value as a 30 here. Getting the point? So this is very important here. Now, right now, what I will do, I will try to provide the same example with the help of debug mode, so that we'll get to know how this particular arrays are creating internally and how this particular arrays are storing the value internally into this particular variable called month underscore days here. Okay, so give me 1 minute. Once this particular ID is open, we'll try to write the same example. Okay, so now, so what I will do, here only I'm trying to define array example. Okay, so I'm finishing this. Now what I will do, whatever we executed here, I will copy and I will paste it here. Okay, I will put a breakpoint here. What happened here? And I'm going to run this as a debug as a Java application. Now if you see, so month underscore days. What is a month underscore days basically here? It is a variable we declare here, and this variable is created here, like it is initialized here. And what is the size we given? The size we given as a 12. Now we can calculate this, how many values we are having here. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, and here these are all the default values. Why we are getting 0 here? Because for this particular into data type here, we are going to get the default values as 0. Okay, now if I'm going to expand this, whenever I'm trying to expand this, now observe carefully what happening internally. So this section is holding the original value, and this particular section is holding the indexes here. Now you can see the index is starting from the 0 and it is end up with 11. Getting the point? It is end up with 11. So whatever the diagram I provided, so it is matching or not? Getting the point? So indexes are starting with 0 and end up with 11. Now observe carefully. So whenever I'm trying to execute the line number 7, so carefully observe what happening in this right side section here. Now you can see what happened internally. So initially it is 0. The 0 value is override with this particular 31 here. 31. So why it is override? Because what we are doing here, we are trying to initializing the value. Okay, same way, first location, second, third, fourth, fifth. Now you can see here, these are all the values are loading here. Now you can observe. So between, I did not like initialize the value. So still these are all the 0 location, like 5, 6, and 7 and 9. We did not initialize any values here, but only on the specific index location. On the specific index location only, I provided the value. Getting the point? Now you can see how many values we are storing here. Around how many? 3, 4, 5, 6, 7, 8. So around 8 values we are storing here. So it's nothing but this particular variable. Now it is holding 8 values, but all the values are having same data type here. Getting them or not? So earlier we did not store these many values. We come up with only one value here. And finally, now what I will do this, because this is the month underscore days is a reference variable. You can see this is only the reference variable here. Right. Now this particular month underscore days, it's trying to move into the third index location and it's loading the value. So whatever the third index location value we are having, the value is going to load it here. So this is the way we can work on this particular one dimension array. So any questions?
Sir, How do you know that we will put underscore in the month and days between?
Basically, just for understanding purpose, I added this. So
Is,
either uh, you can come up with a month and days, like
is
so you can remove this, but that is not the convenient way to read this particular variable name.
okay. So it means that it doesn't affect the syntax if we write something else in between.
See, basically, we need to follow some the variable declaration, like variable creations here. So we can use the underscore, hyphens, all those things, but that we have some limitations here. So the
Okay.
limitation we need to follow here. Okay, I will
Oh,
explain the limitations. So in
okay.
our upcoming classes.
Okay, sir, and one more thing, sir. What do you write in the square bracket month underscore days? So the in square brackets you said that we will. This is basically the index location, right, sir?
Yes.
Okay, thank you.
Excuse me, sir.
Yes.
So here we are giving size, the array size we are giving 12. Initialize we are initializing only 8. So can we do like, is it okay? Of if we, we need to write correct, like how many we need to initialize that number?
That is not a problem. So we can we can come up with a size some bigger. We can initialize whatever the required values here. So basically, why we need to like before initializing the value, first we need to declare the size. Why? Basically, if I'm not in like creating the size, what happens here? This particular array concept automatically it will not grow up the size here based on the initialization value. So the array, we don't have an option to dynamically increase the size. For this purpose, first we need to declare the size.
Mm.
So then only we can initialize the value. So for same example, if you discuss about the array list concepts here, so in the array list, we can without declaring this particular size, we can initialize the value because internally they implemented some code. So for example, let me show you how it's look like. If I'm moving into this, this is the add method. So we are calling internally grow method. This is the grow method is which we'll call. So copy of, and what we are doing this. Now if you see here, again here what is the data type or like object we are creating? Here we are creating object array. So right now we come up with a integer. So here they are creating object array, and after this, what they are doing here, you can see here they are come up with a new length here. So based on the new length, they are creating an objects array, and after this, so they are going to store the values into this particular copy. So otherwise, based on some criteria, here they are checking some criteria. So if they are the criteria is not matching here, they are moving into the new instance here. So they are going to copy the existing value into this particular original. So you can see this is the original array and we are copying into this. And here, so we are checking this particular length here. It should match the length. Based on this particular length here, they are copying here. But internally, what we need to understand, this array list internally, it's checking on the arrays concepts only. But only the type here, we are working on the inter data type, but they are creating object array. So this is also one data type here. We'll see in our upcoming classes how this particular object and object arrays are going to work. Okay. And here, what we need to understand here, let me go to the from first. So if you see element data, again they are using the S. What is the S here? S is pointing as an index here. But observe carefully, element data, if I'm going to open this, we'll go to the first. Try to read here object array. So now you can see this is the default capacity they are providing. So up to 10 values we can initialize, like 10 records we can insert into this particular array. And now you can see this is an object array they are declaring here, and they come up with something like a private static final here. And now you can see they are coming with one more object array. So default capacity empty element data. And now, so you can see this is an element data. What is the type we are having? Object array. object array. And right now, what is an example we are providing? Int type here. Getting the point? So this is only this particular differences. And once we move on to this, now what happening internally? So now you can see based on the capacity, basically this will call it as a constructor. We'll discuss later, but observe what they are doing internally. They are creating an object array based on this particular capacity. And now what we are doing here, you can see, so same data type we are providing int and we are providing the size. Size is nothing but same capacity here. Getting the point? So we are providing the 12 and here we are going to give you the dynamic value. So this is we are going to give the dynamic value. So based on this particular concept here, so arrays values based on the value initialization, but whatever the array we are having, it's automatically grow here. So here also we can grow the same array here, but we need to write some lengthy lines of code here. So first we need to check the size. If the size is matched, then only we can increase like we can come up with one more array, and we need to copy the existing value into newly created array. Okay, so we'll see that also for one example how we can increase the dynamic array size here. So right now we are making static here. This particular
So
12
one,
is a
one
static.
more question. One more
Yes.
question. If we want to write, print all the lines, so do we need to print all that again 12 line system out dot print, or we can do comma month days again? We can do the same thing.
No, instead of doing this, so yesterday we discussed about the loop concepts. You can use the loop and you can print the values.
Okay, got it. Thank you.
Okay, so any other questions?
Question. So you initialized random values for the different indexes, right? So how did you do that? Like when you
Mm,
try
I,
to debug,
yeah.
is it just a keyboard shortcut that you used to do that?
Okay, so that you want to know. So basically, where we want to stop this example, first we need to click. It's a line numbers. Click, double click here. You will get the one dot here. Okay, so what I'm doing here. So line number 7, whatever the compile is running here, it will stop here. The line number 7, it will stop. And after this, so we have a different shortcuts here. What happened? So we need to run as a debug as a Java application, not run as a Java application. So if you click on this run as a Java application, here it is not going to stop at line number 7. But if we want to stop here, we need to use debug. Whenever we are using this particular debug, it will stop here. Now you can see the line number 7, it's time to execute here. And if we want to move on to the next line, so for this particular next line, where is that? One second. Where is this go to? Okay. So here, what we need to understand here, you can see these two on top of here. So we can identify these are the two very important here. These symbols here, this particular symbol, it will move on to the line by line. So whenever you are trying to click this particular symbol, it will move on to the line by line. And whenever you are trying to click this particular array, so this beside one, it will move internally this. So right now we don't have any information internally this, but this section we can discuss whenever we are trying to create a methods, some constructors. So in that case, we can move on to the constructor and we can see what happening internally. Okay. So for this example, we can go for this particular, the arrow. So it will move on to the line by line. And here, instead of clicking on this particular symbols here, we can click on the buttons. Like you can see, this will move on to the F6, step over F6, and now you can see step into F5. Getting the point? You can move on to the F6, F5, and F7. So F5 basically it will move under the method or under the constructor, and F6 it will try to execute the line by line, and F7 if you move any internal code, it will come out of the particular internal code here. So these are all the three shortcuts we can use when we are trying to debug the code. Okay, this only applicable in the Eclipse IDE, but if we come up with a different ID, so there, so we may have different shortcuts here, but the purpose is same. Okay, so any other questions? Okay, so if we don't have another question now, so I will move on to the one more example here. Basically, this example we'll call it as a array initializer. So this section we come up with a object creation, and once object is created, we initialize the value. Now one more example, what I'm doing here, if we observe here, same variable I'm trying to take, month underscore days I'm trying to take here, and I'm declaring this particular the braces here, and now you can see I'm defining this particular section, we'll call it as a array initializer. So basically what it will do, this particular array initializer, it will try to come up with a so two advanced steps here. First, what exactly it will do. Now what I'm doing here, I'm trying to give the values, so something, some random value I'm giving. Okay, some random value I'm giving here. Now observe carefully. So what is the size right now? How we can think here, what is the size here? So basically this particular concept we'll call it as a array initializer, and this particular array initializer what is doing here, based on this particular values, how many values we are giving here, based on this particular values, it will create the size here, it will create the size, and it will initialize the values here. How we are initializing with help of this particular index location 0 1 2 3, how we are initializing, so it will internally it will perform these two steps here. First it will create a size, and second it will initialize the values, how we are initializing like this. So these are all the two steps are going to perform internally with help of this particular concepts here. Okay, and now so directly what we can do, we can use this particular println method to find out the value. Getting the point? So directly I can print this values here. 63 I'm getting. So what is a 63? Like in the third index location, what is the value we are having? Now imagine the first one is 0, second one is first index location, and 41 is will resides in the second index location, and 63 is moving internally third index location. Getting the point? So this is a way the values are going to initialize it with the help of this particular index location. So it will try to look up the same order here. This order internally it will create a index locations here. But here once you created this, now for example here what I'm doing here, month underscore days, and what is the size we are having? So I given as a 10. The 11 index location, something like I'm initializing 45. Now you can see what happening internally. So the size, whatever the size we created, this is the size. So size is 10 values. We can initialize only 10 values. But right now what I'm doing here, so the 11 index location is not available. But even though if it is not available, now what I'm doing here, I'm trying to initialize the value. Getting the point? I'm trying to initialize the value. So this is very important here. Whenever we are trying to come up with this particular array initializer, first we need to check about the values. Based on the values, it will create the size. So once it is created the size, we cannot initialize the value outside of this particular length here. Getting the point? If you're trying to initialize here, what happens internally? So we may get this particular error here. Getting the point? So we'll try to run the example in the debug mode. We'll get to know more information how it is going to work. Now you can see if I'm coming into the next line, now you can see month underscore days. If we expand this, these are all the index location, the left side, and the right side, the original values here. And now you can see 0 to 9. 0 to 9, it is a index location. And what is the size? 10. And what I'm doing here, I'm trying to initializing in the 11th index location. But right now, what is the index we are having? 0 to 9. Up to 0 to 9, you can modify the value. Nothing will happen here. But the problem here, if the size is outside of this particular length here, so then only we are going to get an error here. Okay, so this is we need to understand carefully. And here, for example, if I'm trying to modify this particular 7, now you can see nothing. We are not getting any error. So happily, whatever the value we are printing, the 63 is printing. Because so if we are trying to overriding the value, whatever the earlier value we are having in the 7 index location, so 74. Now I'm trying to override with this particular 45. If you are trying to print the 7, it will print only the 45. Not, it will not print this particular 74 here. So this is we need to understand this particular array initializer here. Okay, any questions? Okay, so if not, what we can do, we'll try to come up with a other data type here. So right now we are discussing interrelated data type. Now what I will do, I will come up with a double data type here. So how we can use this particular double data type here? So it's a simple one. So double I'm creating, and whatever you are interested, you can take this particular variable name, and I'm trying to come up with the same array initializer. So something like, because it is a double data type. Now what I'm doing here, I'm trying to so initializing the value like this with a 12.5 comma 14.8 and 78.4, some value I'm giving here. So this is the double data type array concept here. And now what I will do, so I'm going to find out the array size here, or we can call it as a average value of this particular arrays here. Whatever the double data type value we provided, I want to find out the average here. So how we can find out here? So we come up with multiple values, and after this, so I'm going to use result. Initially I'm going to come up with 0.0, and I'm using into I. So these are all the three variables here. And now what we can do, I'm using this particular loop here. So using this particular loop, now what I'm doing is I'm trying to come up with a result here. So observe carefully, into I is equals to 0. And what is a condition? Because initialization, we come up with a 0. And what we can do, I less than. What is a condition we can provide? So to provide this particular condition, now what we can do, nums dot length here. We can use this particular length here, right? And after this, I plus plus I'm using. Okay, we'll discuss about this particular I plus plus later, but observe I plus plus is nothing but just we are increasing the I value. So either I is equals to I plus 1. So this is the best one. Okay, now after this, now what I'm doing here, I'm moving into this particular result. Result is equals to result plus num of I. So carefully observe here. I'm not come up with any static value. I'm using the I. So what exactly this particular I is working here? Getting the point. So what exactly this particular I? Here, whatever the I variable we are declaring here, this particular I variable is going to work as a index. Getting the point. So whatever the indexes we are having, so this particular I is going to work as a index here. And now you can see what I'm doing here. So result initially it is a 0.0, and I'm trying to do some addition here. And from this particular num of I, so this particular I, for what is the current value of this particular I? It is 0. So in the 0 index location, what is the value we are having? This is the value 10.2. Getting the point. So this particular 10.2 will store into this particular result here, this particular result. Now what happens internally? This particular loop will repeat one more time. Now I value will become 1. Initially it is 0. Now it is become 1. How it is become 1? Because of this particular iteration here. I is equals to I plus 1. So initially it is 0. We are adding 1 value. Now it is become 1. So whenever the I value will become 1, so condition is checking. So what is the length here? So you can see length 1, 2, 3, 4, 5. So length is 5 and I value 1. 1 less than 5. Condition is satisfying here because 5 value is a bigger value compared to this particular 1 here. Okay, once a condition is satisfied, now what happens internally? It will come into this particular line number 24. So what we are doing here, line number 24, again, so result to plus. So what is the result we are having earlier? 10.2. Now 10.2 plus num of I. Num I what is the I value we are having? 1. So at this time, it will try to load this particular value, 11.3. So it will append to, like it will do some addition based on this particular result and number of I, and again whatever the after completion of this particular addition, we are storing into the same result here. We are storing into the same result. Again it will repeat one more time. Now in this time I value become 2, so 2 less than 5. 2 less than 5, condition is satisfying. So at this time we are moving into this particular value 12.5, and later it will move on to this, so 3 less than 5. So 3 is less than 5, still the condition will satisfy. So this is the value will load, and now it will become 4. So 4 less than 5. The 4 less than 5 also will satisfy. So this particular value will load. And whenever this particular I value will become 5, now what happens internally? 5 less than 5. So it's going to check this particular condition. 5 less than 5. This condition will fail. This particular condition will fail you. So this condition will satisfy only 5 less than or equals to 5. Getting the point? 5 less than or equals to 5. So in this case only it will satisfy, but in this case it will fail here. Because so we are checking less value, but here it is not a less value. Those both values are equal here. So finally we are getting the result. Now based on this particular result, now what I will do, I will try to find out the average here. So what is the way to we can find out the average? We can divide the whatever the size we are having. So once we get the whole value, we can divide it with the size, so that we'll get to know what is the average value of this. Okay, let me do that. And here is out I'm trying to write here. And once we define this, I'm going to write here average is here result. Okay, so if I'm trying to print this particular result, we'll get to know what is the value we are going to get. So first one I will make as a sum of results and average. So average here, what we can do, so this particular nums dot length here. Getting the point? So to find out the average here, this is the total sum. From the total sum, we are trying to divide with the whatever the length we are having. Now you can see if I'm going to run this. Now observe carefully. The result, the sum of this particular result, we are getting as a 127.2, and finally this is an average here. So this is an average we are getting here. So this is the way we can come up with another data type called double data type here, and we are initializing the value and we are loading the value, and we are doing some other operations like sum of and average here. So any questions?
I will do some examples today. Can I ask tomorrow this if I have anything doubt
You
about
can
this? Thank you.
you can ask, no problem. Okay, so now we'll move on to the multi dimensions here. So how exactly the multi dimensions are going to work? So right now, what is the dimension example we identified? It is a one dimension example. Basically, the one dimension, so we are going to create like this month underscore days, and we come up with the initialization, and we do the sum operations here. And the same way, how we are going to use the multi dimensions here. So let me come up with one more example to come up with this particular multi-dimension. I'm going to create as a 2D array. Okay, the name of the class I'm creating as a 2D array. So observe carefully. We are creating 2D array and we come up with the main method. And internally, I'm trying to create the two dimensions array here. So this is also I'm going to use the same data type called int only. And now you can see the variable I'm trying to declare as a 2D, and observe here I'm trying to come up with two braces here. Earlier we come up with only one braces, now we are discussing two braces here. Okay, now you can see new, and what we can do, we can create the same the size here, and if you are trying to create this particular size, so you should come up with the same this particular two braces here. So here what we need to provide here, if you see why we are getting an error here, so variable must provide expression or array initializer. So basically is expecting some expression is nothing but some size we need to provide. So for the first dimension I'm giving as a 4, and the second dimension we can come up with a 5. Getting the point? This is important here. The first one I'm coming with the 4, and the second one I'm coming with the 5. So how exactly it will create this? How exactly it will create this? So this is important here. So we'll create the first this particular array dimension here. Okay, now observe 0, 1, 2, and 3. So it's become 4. So the first 4 we created here. And what about the second 5? The second 5 we are going to create like this: 0, 1, 2, 3, 4, and 5. Getting the point? So observe carefully. The two dimension is very important here. The two dimension is very important here. So here we can provide the 0, 1, 2, and 3, finally 4 and 5. Getting the point? So you can see. So this is the fifth size here, and this is for 4. Sorry, fifth size, and this is for 4. Okay, so we identified how this particular dimensions are going to create internally. So we
Sir,
have some idea. Yeah.
I'm sorry, but for 4 it has 0, 1, 2, 3, and then for 5 it is 0 to
Oh,
5.
sorry. Yeah, it's wrong. This is no longer available. Okay, so 0 to 4 it's become 5, 0 to 3 it's become 4. Okay, so now we created the dimension. Now what is the next step here? We need to insert the values. So how we are going to insert the values? So to insert the values, now what I'm doing is I'm trying to come up with this particular some variable declarations. So observe carefully. Okay, here int I comma j comma k. So how many variables I'm declaring? Three variables, and now you can see all the three variables I'm initializing with 0. Getting the point? So this is the another way to initialize the value. The default value we are initializing 0 for all the three variables. So right now we are taking as a I, j, k. Okay, now observe I'm using loop here. So why I'm using this particular loop here? Based on the loop only, we are going to initialize the values, because it is a 2D dimension. If it is a 1D dimension, we can provide the index location. We can give you the values. But when we are trying to work with the 2D, so we cannot make static values here. Okay, so observe I is equals to 0, getting the point, and I less than 4 I'm making, and I plus plus. Okay, so this is the particular outer loop. Outer loop is pointing as a rows, and inner loop is pointing as a columns here. So this is important here. And now I'm using one more loop. Basically, the line number 8, whatever the loop we are creating, this will call it as a nested loop. So the nested loop information we'll discuss in our upcoming classes. But just for understanding this particular 2D dimension, so observe how we are using. Now you can see j is equals to 0 in the point, and j less than 5, because it is a column level condition, and so j plus plus. And now what I'm doing here, I'm trying to come up with a two for loops here. First one is row level, second one is column level, and I'm initializing the value. So how I'm initializing, this is important here. First I'm declaring I, and second I'm declaring Sorry. And I'm declaring as a j. And what is the value I'm going to initialize? I'm initializing the k value. Getting the point? I'm initializing the k value. This is very important. We need to understand. So 2D I comma like I and j. So I is pointing to the row level and j is pointing to the column level. So most of the time here, the I value is not going to modify and j value will modify multiple times here. So that we need to understand very carefully. So observe after this, I'm trying to increasing the k value. K is equals to k plus 1. Getting the point? K is equals to k plus 1. Right now, what we are doing here, just we are initializing the value into this particular 2D. How we are initializing? So now observe, what is the initial value of this particular I? I value 0 and same way, this particular J value also 0. Okay, so here I'm making the condition less than 4 and so here I'm making the condition called J less than 5. Now observe here line number 7. Line number 7, what we are doing here? So we are doing first iteration, the condition is satisfying. So 0 less than 4. Because I value 0, 0 less than 4. Condition is satisfied. Once a condition is satisfied, now we'll enter into this line number 8. Now what we are doing here? So we are checking what is the J value? 0. So 0 less than 5. So this is also will satisfy here. Once it is satisfied, now what is the K value? K value how much? So here I will define. K value also 0. So this particular value I'm initializing here because we are come up with only single equals operator. So it's nothing but the K value we are storing into this particular 2D. So while storing this particular 2D, how we are storing here? I value 0, J value 0. So observe carefully. Again, I'm trying to define the diagram. 0, 1, 2, 3 and 4. Okay, so 1, 3 and 4. So this is the 0 and this is also 0. Which this particular block is pointing here? This particular block. Getting the point? This particular block because I value 0 and J value 0. So this is pointing this particular I and this is pointing the J. Right now, what is the K value? K value 0. We are initializing K value. Now the question here, which loop is going to repeat? So the nested loop first it will repeat. Nested loop first it will repeat. Now the J value will become 1. And before J value will become 1, first what is the value we are increasing? K value. Where we are increasing? The line number 10. The line number 10, what we are doing is we are increasing the K value. K is equals to K plus 1. Initially K value is 0. Now it is become 1. So after this, J value is increased. Now J value 1. So which condition we need to check here? J condition. So what is the value of this J? 1. 1 less than 5. Condition is satisfied. But observe carefully, this I value still 0. I value still 0. We are not updating this particular I value. Only we are updating this particular J. So J value 1. So now which location will point here? This one. Getting the point? So this one will point here. So don't confuse here. So I value, sorry, J value 1. Now it is pointing to this. But still I value 0. The I value 0. We are not moving into this particular row. Still we are in the same row. Just we are moving into the one more column here. And what is the value we are going to store here? 1. Why we are storing the 1? Because you can see the line number 9 the code. So K value, the right now K value we are having 1. The same one we are storing into this particular J first index location. Still the I value 0. Now K value changed here. Same way J value changed here. And here we can check the condition 2 less than 5. So again, so we are moving into the 2 index location because of here 2 dimension. This entire section will work as a 2D only. This entire section is working as a 2D. I value 0, J value 2. So here we are providing the J value 2. And same way K value 3 and J value 3. So it will become 3. Okay. And K value will become 4. And same way J value will become 4. Now 4 value. But K value will become 5. And J value also will become 5. The problem will come here. Whenever the J value will become 5, what happens internally? 5 less than 5. 5 less than 5. Condition is failed here. Once this particular condition is failed, now what happens here? Now it will move on to the outer loop. Getting the point? So now it will move on to the outer loop here. So now I value will change here. Initially it is 0. Now I value will become 1. So once I value will become 1, what happens internally? We are pointing to this particular row. Getting the point? We are pointing to this particular row and whatever the j value. So j value will start from the 5 or j value will start from the 0. Again, the j value will start from the 0. Why? Why it is? Because of here what we are doing here. So here we need to understand here. J equals to 0. J equals to 0. Initially we have a 5. Now again it will become 0. J value 0, I value 1. So here I value 1, j value 0. What is the k value? 5. Getting the point? So this is important here. Whenever it's coming out of the outer loop, it's trying to execute one more time. Every time the j value will start from the 0. Getting the point? This is important here. Every time. So once the j condition is failed, once it is move on to the outer loop, from the outer loop it is coming to the nested loop. So in that case the j value will become 0. Okay, so now you can see j value 0, so k value 5 we initialize here. So same way it will move on to the 6, 7, 8, something like keep on. It will increase, like it will store all the values here. Okay, so any questions? The initialization here into this particular 2D dimensions array. Anyone having any question? Okay, so if not, what we will do? So I'm like clear this particular screen and I will move on to the loading the data. Getting the point? So I will move on to the loading the data. How we can use load the data. So basically I'm going to use this here. We are not going to use this, so simply we'll use a sysout here and I will print this particular 2D I and j. I'm not going to use this particular k and only I will use this particular space and I will come up with a print here. So after this, what I'm doing here, I'm going to come up with this particular println. Control Shift F. Okay, so observe carefully. Now I format the code here. So to understand some readable here. So this section we already identified. It is initializing the data into the 2D array. And this section, it will try to load the data. Again, this also same. So this nested loop will repeat multiple times. The outer loop will repeat only 4 times. But each time this loop will repeat to 5. So around here, this nested loop will repeat around 25 or more than, I think around this will repeat the 25 times here, and the outer loop will repeat only 4 times. So now you can think that nested loop is playing very important role here. Getting the point? So let me run this example. Observe 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and some values here. So first row, second row and third and fourth, and now you can see here all the columns here. How many columns we are having? 5. 0 to 4 is it's nothing but 5 columns here. So this is the way we can initialize the value and we can load the values. Okay, so any questions? Okay, so now what I will do, I'm going to stop the session here. Tomorrow we'll continue. So one more dimension, like how we can come up with the so here we are identifying the 2D. So tomorrow we'll identify the 3D dimension. So how we can use the 3D dimension here. And once we familiar with the 3D dimension here, we'll move on to the what is another concept, operators here. So the basic operators we are going to discuss here. Once we familiar with the operators here, directly we'll move on to the object creations information here. Okay, so most of the I'm thinking tomorrow we are more we'll try to close the operations, and so day after tomorrow we'll try to start the object creations and constructors, methods, all those things we are going to discuss in our day after tomorrow. Okay, so if we don't have anything, we can stop the session here. We'll continue tomorrow.
Thank you, sir.
Thank you.
Thank you, sir.